Hello everyone, this is a brief status update with the mod-erm EKB integration proof of concept. Most of the code is in mod-erm. Some of the code to do with activation isn't in mod-erm, it's just a proof of concept, and our expectation is that it will be implemented properly by another team. It's not in scope for the GBV work, it's just something we're doing to prove the abstract interface by implementing a concrete realization of it. I'm going to start a Vagrant machine. This is the testing box. There you go, folio testing backend. Okay, so that takes a little while to spin up. I will just pause because you don't want to sit here watching that progress meter go. Okay, finished starting up. It's just booting now. While that's finishing booting, so this status report is primarily because we've learned that there are some concerns about whether or not mod-erm will integrate with EKB. We had that on Friday the 12th, so we thought we'd just try and communicate a little bit more clearly about what our intentions are. I can't do you a demo of the UI at the minute because it's broken due to breaking stripes changes, and Mark is just currently trying to put the UI back together with the latest stripes modules, but I can definitely prove the integration. As I think we've said before, our preferred approach to remote KB integration is absolutely to harvest. That's not really a technical thing, that's a user experience thing. By harvesting the remote data, we can give the users a single user experience for selecting packages from any knowledge base provider. They don't need to switch apps to choose content. They don't need to get out of ERM and go into an OCLC app or a 360 app or anything else. We could just provide them with one search interface where they choose packages and then go from there. And it's not just the getting out of the app. We can give them a single set of search semantics, so non-anchored left phrase searching type semantics, which you wouldn't get if you search remote databases because everybody implements search slightly differently. We felt it was a much slicker experience for the users. However, there are business concerns around whether or not we can harvest every remote knowledge base, so we recognize the need to be able to work in different ways. There's nothing in the architecture which precludes different ways of integrating with knowledge bases. It's just that we felt harvesting gave the best user experience and the best product for our users, and that's what we were driving, not any other agenda, but that's fine. From a technical perspective then, harvesting, the reason we liked it was it removed any performance issues with remote sources, so we could completely hide from users the fact that this was a remote source. It would never be not connectable. It might be out of sync for a few days if there were a problem with the remote server, but you would never have to stop working. And of course, when the server came back, you could catch up and you could process all the changes that have been stored up in the past, however long. It gives us some traceability and local audit, and it's properly in line with the distributed domain driven design policy of owning the data that you rely upon, which I think is a way that these things are intended to be done in a microservice type environment. But it doesn't matter. As I said, we've got some non-prefetch options, and we wrote a paper, and in that paper there was an option B, which was essentially like Coral, allowing an ERM module to pull data from a remote knowledge base when you had specifically selected an individual package. So you will use the search services in the remote knowledge base. You will say, yes, I want Bentham Science Complete as it's defined in EBSCO's knowledge base. Let me pull that package in. And then, so on the 10th of September last month, we implemented that proof of concept of pulling a package, and we actually used Bentham Science Complete because Bentham Science Complete was a package definition that we were using for GoKB and for actually we have a static copy of Bentham Science Complete we're using for our development purposes, so it meant that we could do like with comparisons. So that's in there, that's this module here, and it was done primarily to prove the abstract knowledge base adapter. So there's an abstract interface which is a remote knowledge base, and we then implement that using the EBSCO KB adapter class. So we implemented the abstract interface using the EBSCO KB adapter, and there you go. So my mod-erm has come up. If I vagrant SSH there's my CAPI nicely started up. I'm going to run mod-erm run external reg. So this is starting my module up, but it's not registered with a tenant or indeed as a module yet. So we'll just wait for that to finish starting. It's in debug mode so that we can see what's going on. And I'm going to register that. Register and enable. We can see the work being done there. That's the module enabling in CAPI. Okay, so now we've turned on mod-erm and we have enabled it for the DQ client. So I've got a script which is dev ekb scenario. So what I've got is mod-erm, but this mod-erm isn't the usual one we demo. This has got no data in it at all right now. So what we're going to do then is we are going to pull some data from EKB. We're going to pull Bentham Science Complete from EKB, but there's no other Bentham Science Complete in Folio right now. Now, you might think this is a better demo because we're not pulling a fast one on you by secretly already having the title data. Actually, it's a less complicated demo because we don't have to deal with the problem of we've just seen clinical cancer drugs, but with a different identifier from a different remote knowledge base. So this actually turns out is a much easier demo to do, or a much less complicated and much less taxing demo than the one that we've been doing before. But there you go. So what we do is this script will set up some reference data, but the important line is this here, which I have duplicated over here. What this is doing is declaring a remote knowledge base. We're giving it the name of EBSCO. This is the class of the adapter, so this is the implementation of our abstract knowledge base adapter. Here's the URL, so you can see this particular EBSCO adapter is talking to Sandbox, but we could declare a different adapter which was talking to the live service. There are some other properties here which are used for harvesting. Obviously we don't harvest from EBSCO, but you can see down here we've got this flag, supports harvesting is set to false, which is an indication that we can't pull packages from this source. We can only import them on a one-off basis. You'll also see some other properties, activation supported true and activation enabled true. So this refers to the ability of a remote knowledge base to store the fact that I feel that I have activated or switched on a client, a title. Some of the reference data, we don't need to get into that. That's what this script does. A little bit further down then, this script, you'll see we call another URL endpoint, which is pull package. That's this fetch stage. What it's going to do is ask mod-erm to give us all the titles which are currently in Bentham Science Complete. That's this URL here. What the script then does, of course, is to stash our internal package ID in this variable so that we can use it later on. I'll talk about that in a second. Obviously, this would normally be done by a UI, but we're not really sure how this UI should look. And the current best idea is that it would be a button on eHoldings to say push this package into ERM. Yeah, that's our current best bet of the least friction user interface for our users. The other option, of course, would be to have some kind of pull button in mod-erm, but then we'd need pull buttons for each of the different targets we support, and we need to supply different parameters based on the different knowledge bases, because obviously OCLC's knowledge base isn't going to use vendor ID and package ID. It's going to have its own variants, possibly other fields that are needed. So what this approach does is this takes a canonical package format in JSON and pushes it into our knowledge base. What's actually happening behind the scenes is that the EBSCO adapter knows how to construct our canonical package format from the specific EBSCO EKB package format, and this adapter deals with that translation in essence. So that's the place we localize all that information. Yeah, seems to work okay. So what a button on eHoldings would do, one option for what a button on eHoldings would do, is to just ask mod-erm to call this pull package URL with the appropriate parameters for the remote knowledge base, and then mod-erm could pull the package from EBSCO's knowledge base. The other thing you could do, of course, is to construct the JSON package and just push it into us. That could work as well. Of course, it means we have to come up with some authentication protocol between the two things, but that's okay. We then create an agreement, because mod-erm is predicated on having agreements. That's how we don't just switch content on, we put a content item into an agreement and then say this agreement is live, and the agreement is like the switch on or off. That's what that's doing. So we just create an agreement that contains Bentham Science Complete as a package. So this is the equivalent of selecting the package in eHoldings rather than selecting the individual titles. So whenever we detect a change to Bentham Science Complete, that title will be pulled in and activated. The slight difference being, of course, that we track the date and time which titles were added and removed from packages, or activated and not activated, so that our ERM users can essentially rewind over history and see at a particular point in time this title was available in this agreement and it came from this package, but it left this package and hence this agreement on this date, but then it reappeared in this other agreement and this other package on this other date. So we can track the life cycle of our agreements and our content. That's creating an agreement. And then the last mile, if you like, is to call this trigger activation update endpoint, which normally would be some kind of a batch task. But what we're doing is we're using the user interface to trigger this now. There are some technical questions we need to resolve about how Folio batch services authenticate and perform authenticated actions. That's still not entirely clear, I don't think, how that should work in practice, and it's very important for ERM. There'll be a lot of workflow type operations that need to be authenticated, so authentication in workflow again is very important. So that's what this script is going to do. It does everything except for this last mile of trigger activation update. You'll see it's commented out there, so let's just run that. So dev EKB scenario. So it's running, and you can see you just caught there. It fetched 4 pages of titles from the EBSCO API, and now what we're doing is we are creating the package definition locally. There's a lot of cross-referencing to do. The thing I was talking about earlier on, where we have to cross-reference clinical cancer drugs in the EBSCO package definition with the GoKB package definition, so that we can say whenever I'm looking for clinical cancer drugs, I can find all these different packages from all these different providers where it's available. That's what this is doing, and this is the work it's doing in the background. I think there are about 800 titles in that package currently. I'm just going to stop tailing the logs and go into a Postgres console for a second. Because I want to just show you, if I select star from org, what we've got here is our orgs table in mod-erm. the orgs table holds proxy records for records from mod vendors. So wherever we've got a record in mod vendors, we know what mod vendors thinks this organization is. We have a local ID, but you'll see here Bentham Science. It turns out we weren't able to find a Bentham Science org record in mod vendors, so we've just created a local proxy so that we can continue doing our work. We can adjust that in the back end, so we automatically create vendor records or not. These are workflow choices that we need to implement, but the reason for having a proxy object in mod-erm is so that this module can work without forcing changes on other modules. Or we could have workflows that do demand change of other modules, but the point is this particular model gives us that power to be to act differently in different scenarios. The important thing I wanted to show you though is that we've got this org reference, and what we're doing in org reference is popping the ID, the provider ID or vendor ID from EKB. This won't be the eventual landing place of this vendor ID. It's going to go into an org custom property of EKB vendor ID, but for the proof of concept, sticking it in reference was extremely convenient for us. If I select star from package, similarly you'll see we've got a package reference, and that is the EBSCO package ID. Again, in a real implementation that will go in a custom field, EBSCO EKB package ID, not into reference because reference is going to be used for other things, but it was a convenient placeholder. I should say as well, if we already had a record for Bentham Science, then it would have been enriched by the EKB vendor ID. So we can know all about Bentham Science, but then as soon as we see Bentham Science from EKB, we'll just absorb this remote vendor ID so that we know how to switch on content for this EKB vendor in EKB. The same thing happens at the title level. EBSCO title identifiers get stored as a very special title ID, in fact. Select star from identifier. And what you'll see are we've got a number of different identifiers here in different namespaces. 3 different namespaces, so this will be ISSN, EISSN, and this particular one is the EBSCO EKB vendor ID, EKB title ID. So that's how we know which title to request gets turned on. So our script has finished. The last thing our script does is to list all the content which we think we have switched on. And because we created the package for Bentham Science Complete, that's all the titles that are currently in Bentham Science Complete. If I more dev EKB scenario and go down, here's my curl command. So this is the last step now. I'm going to trigger an activation update, and what this is going to do is we have an entity called content activation record. You'll see it's currently empty, and that's the definition of it. For every knowledge base where activation is supported and enabled, we're going to create, or we're going to call the API to say please switch this title on in that remote knowledge base. Now the only remote knowledge base we've got switched on is the EBSCO one at the moment, so what we should see is the EBSCO adapter called once for each title in that agreement that we wish to switch on. So I'm going to cut and paste this curl command here so we can see nothing happening currently. Okay, we call the curl command, and you'll see now this is quite slow because it's doing 1 request per title, and we're not doing HTTP session keep alive, so that's a relatively trivial change that will speed this up quite dramatically, but ultimately we're still dependent on the speed of the remote EKB API. Again, this is something that I think we're better doing offline or out of band, so in the evening rather than when a user presses a button. But what you'll see is each line now, this is genuinely calling EKB's title, provider, package, title endpoint, and it's doing a put request with is selected true to say yes, this title is selected, and this will just continue. But what I can do is, if I select everything from content activation record, this is happening inside a transaction, so we're going to have to just wait for these to finish so that the thing commits in one go. Probably should make this commit on a per row basis. I'm going to just pause while that finishes. In fact, while it's finishing, let me just go through this and just recap what we've done. We started with a completely empty folio and a completely empty mod-erm. We declared a remote knowledge base with the EBSCO adapter, so no GoKB, no statically loaded package files, just an empty mod-erm. We declared the remote EBSCO EKB. We called an endpoint that asked mod-erm to pull the definition of Bentham Science Complete from EKB. We created an agreement that contained the package Bentham Science Complete. It could have contained individual titles or Bentham Science Complete and some other individual titles. Once we'd done that, we called the trigger activation endpoint. The trigger activation endpoint called out any adapters where activation is supported and enabled, which in this case just happened to be the EBSCO knowledge base. What would normally happen next, of course, is that tomorrow night we would fetch any updates to Bentham Science Complete from EBSCO's knowledge base. We probably have to do that by fetching the port for the full package definition and doing a difference. That's implemented. That will just work with no effort on anybody's part. That's already implemented. If we can get deltas, that would be better, but we don't need it. We can just do a difference between the two packages on 2 different days and figure out what titles have been added and what titles have been removed. And then we rerun activate, and any new titles that have been added we'll realize we don't have a content activation record for, and we'll call the endpoint. Once we've successfully called the endpoint, that's when we create the content activation record, because we know it's been switched on, and that's how we know we don't need to switch it on again. I think that's finished now. So there we go. There are our content activation records. You could see we've got the date they were activated down to the millisecond, and obviously the deactivation date is null. So this will stay null until we detect a title has been removed, or a title has been forcibly removed by the ERM user, and then we'll switch it off. So we'll call is selected false on the endpoint, and on that point we'll set the deactivation date here, so we'll know the ranges on which we think it was activated in EKB. And if I just page through this, you'll see 408 rows. So 408 titles switched on. So that's it. We have round-tripped mod-erm with no data pulled from EKB and then pushed back to EKB with our selection. Sorry I can't demo a UI. As soon as we're caught up with the latest Stripes changes, we'll do this in an API with a UI demo instead, but hopefully that proves the concept. I hope that was useful. Okay, bye.